in the books. Thank you all for your patience there, and getting moving. So as Jim mentioned, this is the second of 4 webinar series about unpacking the information that was provided as part of the Middle Cedar project, which is the integrated ACPF and PTMAP application data. So I'll start it out with a quick round of introductions. We'll go over a quick overview for what we'll be talking about today, do a quick review about workshop 1 as well, since we had a weekend in between here. Then we'll move into how we can use the information that's in the Middle Cedar project to make sure that you can select the best practices to meet your water quality goals. So just as a quick round of introductions, and I'll let the folks from HEI that are on the screen here introduce themselves as well. My name is Rachel Ulm. I'm a watershed planner with the Houston Engineering Office. I was also involved in the Middle Cedar project and have had the good fortune of meeting many of you on this call today, so it's nice to see you all remotely. With that, I will turn for introductions over to Drew.
Hey everybody, I'm Drew Kessler. I think I've also met a number of you on the phone call, some virtually, some over the phone, some in person. I'm a principal and project manager with Houston Engineering, and I lead our water quality service sector.
All right, and Rob, if you'd like to introduce yourself.
Rob Davis with Houston Engineering out of West Des Moines. Did the first webinar and just continue to tune in to continue to reach out and answer any questions that might come up throughout the webinar series.
And lastly, we have Kaya from the HEI team as well.
Yep, this is Kaya Sagami. I'm just kind of sitting in here. I'll be doing the very last webinar, so just seeing how everything goes today.
Wonderful. And to start the discussion off today, we would like to again do a round of introductions, much like we did last time. Just finding my cursor here. As far as the people that are on the screen here again today too. So if I look over into the distance over here, it's just because that's where my other screen is, not that I'm looking into oblivion. But would like to do a round of introductions to everybody as well, just to hear who is on the phone. Last time you were kind enough to provide your name, your agency title, and role with the Middle Cedar watershed effort. And last time we asked you about your anticipated use for IAPA data. We would like you to repeat your name, agency, and title as well, just so we can better familiarize ourselves. But since we've had a weekend in between from Friday until now, wondering if you could share just a sentence about something enjoyable you did over the weekend as well. So I will call on people as we go around here, and the first person I've got on my screen here is Mary Beth. If you want to kick us off, put you on the hot spot.
Hey everyone, I'm Mary Beth Stevenson. I'm with the City of Cedar Rapids. I'm the Watersheds and Source Water Coordinator here. And over the weekend, I went camping at Lacey Keosauqua State Park. So it was a good weekend for camping.
Lovely. Thanks, Mary Beth. And Jason. Jason, let's see if I can unmute you for you. Let's see. I don't think I can do the unmute. There you are.
Okay, Jason Gomes with North Iowa Agronomy Partners. You do a lot of outreach work for IDLs and then the Middle Cedar Watershed Management Authority in the Middle Cedar Watershed. And this weekend, I went to Galena on Sunday. And so it's kind of a date day with my wife. We had one of the older kids watch the baby, so.
Lovely. Always nice to get out and have a little break too. And congrats on the new one.
Well, I mean, she's not new. We call her the baby because she's so much younger than the others. And I'm on Casey's Wi-Fi in case anything goes awry here.
We gotcha. If anything goes awry, I'll just blame it on your Wi-Fi instead of any other circumstance.
But if anybody finds themselves out in the countryside stranded, Casey's has great public Wi-Fi. They really do. You can just pull up in the parking lot and you're set.
Perfect.
All I got to say about that.
And over to James Martin, please.
Hello, everybody. James Martin with IDLs. I'm a regional watershed coordinator. Southeast Iowa is my territory, so help the individual district projects mainly with technical support. A lot of the time, which is GIS related stuff like ACPF. So this weekend, I'll keep on the outdoor theme or whatever. I was at Yellow River State Park camping. So what a nice weekend it was to do that.
Great. Thank you, James. Everybody's making me jealous. Shane Wolf, you're up next on my screen. And we don't have audio coming through for you, Shane.
Hear me now?
Yes, we can. Thank you.
Okay. This is Shane Wolf, Idaho Department of Agriculture and Land Stewardship. I serve as the Edge of Field coordinator. And this weekend I went to Hitchcock Nature Center in the Luss Hills and did some camping out there. So it was fun.
Great. And Jeff Tizzle. If I'm pronouncing your last name incorrectly, I apologize.
Close enough.
Wonderful.
Jeff Tissel, regional coordinator for Northeast Iowa, do the same thing as James, just not as well. And this weekend I went out and had an opportunity to do a lot of photography, nature photography. So
Great. And Matt McDonald, got you next.
Yeah, I want to say thank you to Jason for letting me know about the Casey's Wi-Fi. So, Matt McDonald, I work for the Iowa Department of Ag and Land Stewardship. The official title is WQI State Projects Coordinator. I work a lot with the regional coordinators that are on the call here, and of course with Shane and the watershed coordinators also. So, yeah, thanks for the invite. And what I did this weekend, not quite as cool as camping, but we went to a couple graduation ceremony or parties after that, and did some grilling outside. So
Great. Alrighty, next we have Rose.
Hi, everybody. Good afternoon. Rose Danaher. I work for IDOLS as a project coordinator in the Middle Cedar watershed. I manage the Benton-Tama project in Benton and Tama counties. And what I did this weekend, it finally cooled off enough that I was able to work my bird dogs on birds. So that was awesome. And shot a gun over my puppy for the first time. And that went well. So getting ready for October.
And hats off to the puppy, too.
She did well.
And then we've got our colleagues from IAWA. We have Jim, Sean, and Caitlin on the line. Would you guys like to do introductions as well? Up to you. Jim, let's turn it over to you and just do a quick hello.
I'll just say hello to everyone again. And my weekend activity was washing gravel for the landscaping, washing the mud off of gravel. So that's what I do for fun. So that's it for me.
Great. And Sean, we've got you on the line as well. Good to see you.
Hey, good to see you as well, Rachel and everyone else. So Sean McMahon, IWA, had a wonderful weekend. Wound up in the water and on the water a lot. Kayaking and hanging out at Raccoon River Lake Beach Park. Nice little place. And also went birding in Walnut Woods State Park. So yeah, two of the Des Moines Metro's finest parks.
Great. And last but certainly not least, our hostess, Caitlin.
We actually had one more person just join.
Oh, thank you.
I'm sorry, we are having another person. Okay, so we've got two new people joining, and then I'll make mine quick. So Caitlin Little with IAWA. I'm the program coordinator, and this weekend I also went to Raccoon River Park. I went kayaking with my roommate. So that was really fun. We did the tandem kayaking, which really made us better roommates, I think. But you know, yeah, it gets the teamwork going, that's for sure. And
Perfect.
People who just joined were Schaefer Ridgeway and Adam Keel. Okay.
Schaefer, welcome to the discussion. Wondering if you're willing to give a quick introduction with your name, your agency, and just a quick sentence about something you enjoyed from your weekend.
I'm Schaefer Ridgewin with NRCS. Been around for a long time, probably 20 years with those guys. And fun from my weekend, huh? My weekend was filled with picking sweet corn. We picked about 2,000 ears of sweet corn, so I'm sweet corned out. That's all the fun I had.
That's a productive weekend.
Yeah.
And then lastly, Adam.
Thanks. Adam Keel, Iowa Soybean Association. I guess I went paddleboarding this weekend on a lake near Des Moines, so it was pretty fun. So
great.
Thanks.
Well, thank you all, and thanks for sharing a little tidbits about your weekend. It's always nice after we end on a webinar on a Friday, start again on a Monday, especially a Monday right after a lunch break. So appreciate you all sharing a little bit about how your weekend went, and really I'm looking forward to the discussion today. So with that, I'll get my mouse over to the right panel here. All right, so with just to dive in a bit with a bit of overview for the purpose of why we're all here today. IAWA did subcontract with HEI going all the way back to 2018 to develop some scalable watershed planning products. And out of that effort came the IAPA, which is essentially a stacking doll of acronyms. It's the Integrated ACPF, or Agricultural Conservation Planning Framework, and PTMAP application, which is a Prioritized Target Measure application. And I'll be going into a little bit more details about what that is, just as a refresher from Rob's webinar on Friday. But our overall goal of these workshop discussions here are really to unpack the information that's in that IAPA databases that were provided as part of the Middle Cedar Watershed Project, to ensure that they can be used to guide conservation efforts and be utilized to their best purpose possible. What I'll be focusing today on is how to use the information that was delivered as part of Middle Cedar to really inform investment in order to accomplish your local water quality and sometimes water quantity goals as well. We'll also be going into a bit of a feeler about what's coming up in the next two webinars, which is using this information to inform investments from more of a cost efficiency and return on investment perspective. I know on Friday, several of you mentioned that ROI and wanting to use that to inform your conservation investment. So Drew Kessler, who's on the line, will be leading that webinar for that third webinar to go over that and how you can use this information to leverage and successfully engage producers as effectively as possible about outreach that they may want to pursue. And Kaya and Drew will be providing that information more in depth in the fourth webinar. So again, my webinar and our discussion here today will really be focusing on how we can use IAPA information to target location for conservation practices upstream. I'm going to go into a bit of a first webinar review just to kind of dust the cobwebs off from what we discussed on Friday. If you recall back to Friday too, we were having a little bit of technical difficulties with the live review of how to use the information. So I will be taking a pause point during our discussion today in order just to make sure that we go back to that and I can kind of show you the end of that discussion about how to identify hotspots on the landscape at a catchment scale, that 40-acre average scale for targeting conservation efforts, before I move into the second discussion, which is about how to identify practices based off of measurable goals. So if you recall, all the way back to Friday, the primary goals of that webinar were to identify where are the places that you want to target your conservation towards. Is it an impaired lake? Is it a sub-watershed that's been a priority? Is it the larger Middle Cedar watershed area? And once you identify the area that you're most concerned about, what are the benefits that you want to see? Do you want to see the benefits at that resource? Do you want to see the benefits leaving the field? And how do you identify practices accordingly? So to start way back to what is the IAPA, this is again that kind of combination of acronyms I was mentioning earlier. It's the combination of taking an ACPF information which is a really robust source of information about where there is feasibility to implement conservation practices on the landscape. This is a really valuable tool. It's been utilized in many locations throughout Iowa. But what ACPF does not have is information about what are the benefits of those conservation practices and what are the costs of those conservation practices. That's where IAPA brings in information from the prioritized target and measure application. So by combining the location of practices on an agricultural landscape that is accomplished through ACPF and the water quality benefit and cost information that's provided from the prioritized target and measure application, the IAPA information combined together allows you to look at where are those most cost-effective practices that are going to give me the biggest bang for the buck in my investment for improving a resource that I'm working to manage. So that's really what the overall goal of this IAPA information is. The IAPA information, again, did come out of a project with the IAWA and is summarized in a Middle Cedar Technical Memorandum. There are a series of different resources that are available on the screen here. And again, this information will be recorded. The slides will be delivered as a PDF as well. So you're able to revisit this information whenever you would like to. Click on the live links that are on this screen as well, just to dig into a little bit more of the mechanics and the technical details behind what ACPF is, what the prioritized target and measure application is, and how those two information sets can be merged together and have been merged together to create IAPA, or the Integrated ACPF PTM Application Data Products. So IAPA data was created for the Middle Cedar watershed and was provided as a deliverable in a series of different geodatabases shown on the screen here. Both clustered as ACPF information and as PTM app information. And the areas that we're going to be focusing most of our discussion today, as well as in the third webinar and fourth webinar, are in these output processing geodatabases. This is really where the products are stored from the IAPA project. There is a lot of information that is provided from IAPA. A lot of information goes into it from an input perspective. So the ACPF information is run first, and then it's also run through that IAPA or the Ingest ACPF platform in order to create a lot more information. I show this data on the screen not to insinuate that anybody would be ingesting all of this information right now, but just to show that there is a lot of information that's provided. What I really want to focus on, though, is shown in the red box here. What I'll be focusing most of our discussion today about is how do we tie and connect a lot of the practice benefits and practice cost information to the ACPF locations of those conservation practices on the ground, so that you can have that information to inform your conservation practice investments. So with that, I'm actually going to do my first technological experiment here, so that I can go back to bring back up the live demonstration of how we were going to identify hotspots on the landscape for conservation practice investment that Rob was showing on Friday. So we wanted to make sure that we weren't losing that information. We had a virtual machine uncooperative for us during that demonstration. So I just want to pick that application back up. So where we left it on Friday is we had zoomed into these two areas that are the focus or the area of interest for purposes of this webinar. These are priority point 60 and priority resource point 61. What I'm going to be showing you today is how we can tie in the catchment information as Rob was introducing. So these are the 40-acre or so areas on the landscape that are used to summarize PTM app and IAPA information about how much sediment is coming from the landscape, being delivered to the field edge, and making it all the way to a resource point that we're interested in. So what I'll be walking through here is how we can use IAPA information to identify where are the soft spots on the landscape that are contributing the most amount of sediment, nitrogen, or phosphorus that's making it to the outlet of these two planting regions that we're concerned about. As I go through this, Drew, if I am missing anything that you think would be pertinent, please feel free to interrupt me at any time. And again, if there are any questions, folks on the line, please feel free to interrupt me at any time as well. Zooming back out really quick to the why are we doing this? As you see on the screen here, there are a lot of gray, blue, orange, and pink shapes that are on this aerial photography. What that's showing is all of the feasible practice locations that ACPF has churned out. So this is showing the places on the landscape where you have technical feasibility to support conservation practices like nutrient removal wetlands, grass waterways, saturated buffers. All of that information and that wealth of information is provided by ACPF. What I'm going to show you now is one way that you can use this IAPA data to help you narrow down where you're actually going to invest your dollars, because we all know you can't spend money on all of these feasible conservation practices on the landscape. So you want something to guide your investment. What I'll be showing you in this just very brief example is how you can show those catchments that are that contribute the most amount of nitrogen to the priority resource point outlet. And you can use those soft spots to identify the best catchments to invest your conservation dollars in. And it might be useful to start conversations with those landowners first. So what I showed on the screen earlier was a series of different tables that I'll be focusing my discussion on today. The first table that I'll be demonstrating is this table P-Res catchment route. So I will be using these long names for these tables throughout this discussion as well, and I'll be showing kind of a mapping legend about what all of these tables mean in just a moment as well. But what this table does is it provides information about how much each of these catchments contribute to the downstream priority resource point that you're concerned about. So if you open this table, and we know from our last webinar that the priority resource catchment number that's associated with the priority resource catchment we're concerned about is catchment point number 60. So you can select by attributes to find the priority resource catchment that you're concerned about. So in this case, again, picking up from where we left off on Friday, what we're concerned about is priority resource catchment ID number 60. So that selects 326 different records that we're interested about. It's records about the different catchments that are included within the priority catchment area that we're concerned about. From here, we can export the data and kick it to a different geodatabase. I'm not going to here just because nobody wants to watch information get saved on a slow computer. So I'm just going to close out of here with these 326 fields selected and go to where I've saved that information here. So I've already exported that data. These are the same 326 practices. So it is a lot of information in this table, but once you, and with the information that's provided and the attribute catalog shown on this separate screen, you can identify the information that you are really interested in. So for us right now, we're interested in where are the soft spots on the landscape that are the largest contributors of nitrogen downstream to the outlet of the sub-watershed that we're worried about here, this priority resource point number 60. The field that we look to in order to get to that is the PR. I'm just going to find it first so I'm not doing it from memory and talking at the same time, because I'm a terrible multitasker in that way. This PR means priority resource delivery that we're concerned about. TN means total nitrogen. And the mass of pounds per acre is showing the yield of that particular area. So this is really what we're concerned about here, is PRTN mass pounds of acre. So you can, if you would like to, sort ascending or descending to identify what is the catchments that are really contributing the most mass per pounds per acre in this particular subwatershed. Then what you want to do is go back to your catchments here. So right now we've got the catchments, or these 40 square or these 40 acre areas here. And there is some useful information about the catchments, such as shape area, which Rob showed on Friday. But there's not information here yet about how much these catchments are contributing downstream. So what we want to do is simply join this information to the exported data that we just created. So I'm just going to show a simple join here. You go to joins and relates, and we join this information. I'm going to join it using the catchment ID. I'm going to join it to the table that I just kicked out. I'm going to hit OK and see what that did to the information. So now you'll see all the information we were just looking at for nitrogen loading is connected to each individual catchment. This is helpful because you can visually see the soft spots on the landscape now that are connected to a geographic location with catchment. So if we go under properties, we can just quickly identify what all of those look like. So if you recall the lovely long list I was saying earlier, this PR, TN, mass per pounds per acre, translation means where is the most nitrogen coming from, nitrogen yield coming from on this landscape. We'll just break it into three different classes here. You'll have that information pop up here. So you can actually see where are those soft spots on the landscape for contributing nitrogen, which makes it to the outlet of this subwatershed that we're concerned about. So this might be able to be, or this may be used in your conservation efforts in order to target conversations with landowners about how to implement practices in their particular area.
Rachel, can I interrupt with a question? This is Jim.
Absolutely.
If you could, you or Drew could just chat a bit about, what's built into the assumptions as far as the nitrogen and phosphorus losses, and that we don't have great detail at what every producer is doing in every 40-acre catchment, but what kind of drives those differences in nitrogen and phosphorus? I mean, the phosphorus, one can think in terms of soil erosion ties, in terms of particulate phosphorus, but any comments about management versus how the model is looking at the nitrogen and phosphorus loss data?
Yeah, great question. And I am going to pass that baton over to Drew, who lives and breathes this data in a more technical format than I do. So Drew, if you would be willing.
Sounds great. And if it looks like Rachel said that I'm staring off to the side, my monitor's camera's over here, my presentation's over here, so bear with me. Great question, Jim. By default, what we do is we use land use coefficients for the starting point of how much nitrogen or phosphorus could be lost. So you're spot on, Jim. We don't know, for instance, if in some of these dark blue areas they already have like 4Rs plus in place where it's probably already dealt with a lot of the excess loss. So this is really looking at public information on land use and literature values on how much those land uses generally lose in terms of total nitrogen, total phosphorus. For the sediment data in this database, it's based upon Russell. And again, we don't have detailed information on, for those of you familiar with the Russell equation, P, so the practice factor. This is weird because I don't know where to stick my hand, so you guys see what I'm doing. Or M, the management factor. So those both get kind of set to a default of we don't know. That being said, in both of those instances, if you were to go back and use this data again, if the user has better knowledge, they can change those default loss coefficients, or they can change the factors for Russell to adjust all that. The final thing the user has to do, if you're working with this locally and you have more refined information for a subwatershed, you can scale all this data to either fit one monitoring location, or if you have like a calibrated water quality model. This one is not calibrated, it's empirical based upon literature. If you have a calibrated water quality model, there are methods to scale all this to fit the loading estimates from those water quality models. That cover it pretty well, Jim?
Yes, thank you.
Perfect.
All right, great. Well, that is the live demo we wanted to circle back from our discussion on Friday. I'm just going to minimize it so that if there are any other questions, we can certainly jump right back into it. But with that, I will just jump back into where we left off and get back to webinar number 2. Sound okay to everybody? Okay. So as I mentioned a bit in the discussion, we have these 2 sub-watersheds that are really the focus area of our webinar efforts today. And as I showed on the screen just a moment ago as well, there are many feasible practices that ACPF kicks out that are capable to be implemented, technically feasible for implementation. And this information is really useful when it comes to identifying practices to implement on the landscape. But from a practical implementation perspective, it's useful to be able to narrow that suite down based off of where the best practices may be on the landscape for making progress towards your sub-watershed, your watershed, or your specific resource goal. So what I'm going to be showing during this discussion here is how we can narrow down this information to identify what are the best practices that you can implement based off of your goals downstream. But you can also trim this information down based off of identifying what are the most cost-effective practices. Drew will be spending some time on that during webinar 3. Based off of the type of practice, maybe your landowner is only interested in nutrient removal wetlands, so you can identify those types of practices, and many other different criteria you can use to identify what does really define that quote-unquote best practice that you'd like to implement. For purposes of today's webinar, we're going to be focusing on the best practices based off of your goals, with a little bit of lead into how you can use this information in a cost-effective way as well. So again, these are the 2 sub-watersheds highlighted in the teal in the middle of that screen there. The headwaters of Prairie Creek and the Prairie Creek or Village of Van Horn are the 2 sub-watersheds that we're really highlighting, that were introduced during the first webinar as well. And again, as a refresher, those are priority point 60 and 61 in PTMAP information. That 60 and 61 just means those green dots that are at the bottom of each of these subwatersheds. Those are the PTMAP priority resource points where information gets delivered to. Those points are usually placed at the outlet of planning regions, but can also be placed at an impaired stream that you're working to manage, at an impaired lake, at a wetland that you're concerned about, really wherever you'd like to get information, water quality benefits, loading information delivered to. So again, what we're going to be showing during this webinar here is how we can use IAPA information in order to select the best practices, quote unquote best practices for purposes of this webinar, using water quality local goals. So there can be multiple metrics that are utilized in order to select the best practices. Your water quality goals may be based off of sediment, maybe based off of total nitrogen or total phosphorus, or you can even have a water storage goal that you're working towards. In this case, the Headwaters Prairie Creek Huck 12 sub-watershed here does have a sub-watershed plan. And that's what we use to base this webinar off of. So according to this sub-watershed plan, one of the local water quality goals is to attain a 41% reduction from non-point sources within this sub-watershed. And that's just to be consistent with what's included within the Iowa Nutrient Reduction Strategy document. There's also a 29% reduction for non-point sources for total phosphorus as well. For right now, we're going to focus on nitrogen, and in a later live example, I'll be showing you how to apply this same methodology that I'm showing for nitrogen for total phosphorus. I also know that there's some folks on the screen or on the webinar that are interested in edge of field benefits instead of benefits at a priority resource point. So I'll be going over just a very quick live demonstration about how that information can be shown as well. But For purposes of the PowerPoint, prior to a live demonstration, I'll be showing how IAPA information can be used to select the best practices based off of their nitrogen benefits to the downstream outlet of this planning or priority resource area, which is this area right here. I'm hoping people can see my cursor. So to start out, you know that you've got
Hey, Rachel.
Yes.
Just as a heads up, your cursor is coming through, so if you want to keep using it as a guide, it's perfect.
That's wonderful. I appreciate that feedback. So as a starting place, you know you want a 41% reduction. It's pretty helpful to know what is the current load in the watershed as estimated by the IAPA. So that's where we'll start, is figuring out what's the existing load to get to what is the load that we're trying to attain in that 41% reduction. This is the table I was mentioning earlier that was introduced during the first webinar, and you'll see many times throughout our discussion today. These are the tables in the IAPA deliverables that are really useful just for tying a large suite of information to a geographic location, like a BMP or like a 40-acre catchment that's on a landscape. So there is a lot of different information, and different kinds of information are provided in each of these tables. And we've got a table of contents, or essentially a key for each of these tables shown on the screen, just to guide the discussion today as well. For purposes of this discussion right now, we are looking at the table P-res catchment to figure out what's the existing loads that are delivered to the outlet of this subwatershed that we're concerned about, this Prairie Creek watershed. What the table P-res catchment provides information on is the loading information to the priority resource point of interest. So in this case, that priority resource point number 60 for sediment, total nitrogen, and total phosphorus. So moving forward with that table P-res catchment, you'll see that's shown just on the upper left-hand corner of this table here. If you jump into ArcGIS and pop open that table, you'll have information about the existing loads that's delivered to each of these priority resource points throughout the Middle Cedar watershed. Again, we're most interested in, for purposes of this example, priority resource point number 60. So you have the area of that subwatershed. You have several other different metrics that you could be interested in, like what's the annual loading of sediment delivered to that priority resource point, what's the total phosphorus delivery to that priority resource point. What we're interested right now is what's the total nitrogen delivery to that priority resource point on an annual basis. And we have 466,841 pounds per year of total nitrogen that's delivered to that priority resource point. Just doing some really simple arithmetic in order to calculate what's our target total nitrogen goal. If you multiply that $466,000 pounds per year, of total nitrogen by 41%, the target that we're looking to hit for purposes of this webinar discussion and demonstration is 191,000 pounds per year of total nitrogen reduced. So just keep that in mind as far as the target we're looking to hit. And again, that's identified in one of the main tables that I'll be discussing today, the priority resource catchment table, or table P-res catchment. So again, we've got this 41% load reduction target identified. So our next question then is, what are the practices within this subwatershed here, within this Prairie Creek, Headwaters Prairie Creek subwatershed, that are best suited towards meeting that goal? And again, you just want to make sure that you're connecting the right table to the geographic information you want to tie this information to. So there are three tables that are really useful and that I'll hit on a little bit today from a BMP decision point perspective. So this table BA BMP all catchment, and table BA load red are 3 tables that we use very regularly to identify what are the best practices. So we tie this table information into the geographic location of those practices to connect the dots on those 2 pieces of information. There is a lot of information. Actually, you know, I'm just going to go really quickly high level about what these 3 tables are, excuse me. The BA BMP all is a table with BMP cost and efficiency information at the practice location. The BA BMP all catchment is this BMP information location delivered to the catchment, so that's the edge of the field. And this BA load red is the BMP efficiency information at a downstream point of interest. So think the outlet of the Prairie Creek watershed that we're working on in this example. So all of these information, or all this information about table names and corresponding table information is summarized within this attribute catalog link as well, if you would like another source of information about how to essentially have a legend for this type of information.
Rachel, we have a question in the chat.
Oh, thank you.
Tackle that now. That do the benefits suggested per site include all benefits from other BMPs upslope, meaning cumulative benefits, or only at that site for that individual BMP?
Great question. And Drew, please feel free to jump in if I butcher this response. But it is information that's individual of each individual BMP working by itself. They can be combined together for a cumulative benefit, or they can be run through a separate tool called the treatment trains that allows you to understand the combined benefit of practices as they move forward in treatment line with each other. Drew, anything to add there?
Yeah, you got that spot on, Rachel. And maybe just the reason it was set up that way, to do that kind of treatment train, everything operating together, the computer power is much more intensive. So through the stuff we're demonstrating here today, we're recommending looking at individual BMPs to kind of target or prioritize where you might work, just because the computer processing is much more efficient. As you can imagine, if you stick 10, 50, 100, 1,000 of these things on the landscape and have to crank through all the data analysis, it can take quite a while for that computer to think.
All right, any other questions? Sorry I missed that there, Jim. Okay. Moving right along then. Something that I'll be bringing up just a bit during this discussion, both from a screenshot PowerPoint example about how use this information, as well as in the live demonstration, is some information about how this different information is presented. Oftentimes, we are relying on a unique BMP identifier to identify one specific practice as it differentiates from a different best management practice. We're commonly using median benefits to summarize the practices that we're looking at. That's denoted by the key Q2. However, there is information about the minimum, maximum, first quartile, third quartile available as well, should you like to use that information instead. And lastly, what we are using for this example is the 2-year storm event size. There is, again, still information provided about the 10-year storm event size as well. But for purposes of our discussion, we'll be using the 2-year just to summarize the benefits of these practices. Practices can be summarized either at the edge of the field, which is shown by a C underscore, or at a resource point downstream. Since it's a resource point, that code is the R underscore value. So just kind of wanted to give a little bit of a summary about how these different information is totaled. So what I'll be showing in my live example about how to identify the best practices to meet your total nitrogen goal is I'm going to be using this table here, because what I'm interested in is how do I select the best practices for meeting my 41% total nitrogen target, and where I care about that target being met is at the outlet of the subwatershed that I'm working to manage. So based off of my review of these different tables here, this is the one that really fits my business needs for purposes of this webinar. So I'm looking for BMP efficiency at the priority resource point or the subwatershed outlet. We'll be using the table BA load red for this discussion here. So very similarly to what I showed with my quick demonstration of hotspots on the landscape, a lot of the information within the IAPA deliverables is best suited just with a simple join for joining a table of information to an attribute or a geographic location that you care about. In this particular example, we're looking at joining the load benefit information of all of the practices that are located within the subwatershed of the headwaters Prairie Creek. So I'm joining that table BA load red information to the practice locations within that subwatershed to understand where are the best practices to implement. And I'll be going through a live example of that in just one moment. What I'm most concerned about for this particular joining example is where are the best practices for reducing nitrogen downstream at the priority resource point. So once I've got these two tables joined up, I'm able just to sort based off of this field in the newly created table. That R underscore, which as we just went over is the resource point. NQ2 means I'm looking at the medium benefits of that practice for reducing total nitrogen, and O2 meaning the 2-year rain event. So by sorting based off of that, I'm putting the best practices for reducing nitrogen at a resource point outlet at the top of the list. Once I have that list organized by best on top, worst on the bottom, I can pick the best practices that I'd like to highlight for their impact on attaining a goal downstream. For purposes of this example, just to be really simple, I selected the top 20 practices within the subwatershed area in order to highlight. These could be the top 20 practices that you look for field verification, or the top 20 practices where you get on the phone and call a landowner to see if they're interested in implementing a practice. But these were the best practices identified for reducing nitrogen downstream. It also provides information not only about the benefits of those practices, but about what types of practices they are as well. So here we have a few drainage water management practices were identified as the best for reducing total nitrogen downstream, as well as some nutrient removal wetlands. Lastly, you can identify what's the overall benefit of these top 20 practices towards meeting your load reduction target. So by using just a really quick right-click summary in that RNQ202 summary, you can identify or you can populate the statistics for the top 20 total nitrogen practices. So just getting a rough sum of that, we're kicking out 39,694 estimated, 39,694 pounds per year of total nitrogen at the priority resource point outlet. What that means is we're making almost 40,000 pounds per year progress towards our 191,000 pounds per year goal, which means we're about 20% of the way towards our overall total nitrogen goal just through implementation of the top 20 practices. So it's really a way to demonstrate how attainable it is to accomplish a target load reduction goal, how many practices it's going to take to accomplish a target load reduction goal, and where those practices are located on the landscape so you can really get to work as local practitioners. All right, does that all make sense to folks? And I'll pause here for just some quick questions before I jump into a live demonstration. So any questions first? I'll pause for just one more moment. Yeah, go right ahead.
Say, encourage people to not be shy if have any clarifying questions.
Absolutely. And I'll also make another pause point for questions after this discussion as well here. Okay, but hearing none for now, and in the effort of moving forward and wanting to respect everybody's time, again, just want to show, these are the two sub-watersheds that we're showing for places where there are essentially just the sub-watersheds that we're highlighting for purposes of this webinar. Again, there's a ton of feasible practices that ACPF has churned out. One thing to note is these practices do come as individual practices as part of the IAPA deliverables. So for example, biofiltration practices come in one shape file, storage practices come in another, soil reduction practices or source reduction practices come in a separate shape file. So something that you do want to do straight or before you start doing any of these practices is just merging the files that you're interested in. For purposes of this webinar, we merged together all of the feasible practices onto one, just so everybody could see everything in one eyeball. But if you are interested in just looking at biofiltration, you can also do that. So again, we've got this information about all of these feasible practices on the landscape. And there is quite a bit of information that is churned out about each of these practices without doing any joins by themselves at all. So for example, you have information about what types of practices they are, what treatment group they fall into, what treatment volume they're anticipated to handle, what the size of their contributing watershed is delivered to the practice. So it is quite a wealth of information. Before I go into showing how you can identify, well, actually, before I go into that, you may recall that the field that we are interested in for purposes of this example is the RNQ202, which is right here. And you'll see these values are all null. This is because we haven't gone through the process yet of joining this BMP information with the table data provided from the table BA load read, which I showed in the PowerPoint screen. So I'll just walk you through how to tie together that information again, so you actually have this information associated with all the practices on the landscape. Before I do that, one thing that I would like to point in, because I do know we have some folks on the line here that aren't as interested in a downstream resource point and want to know what's the benefit of practices at the edge of the field. That information, since it's not tied to a downstream priority resource point, is already included. So if, for example, you were just wanting to identify where are the best practices on the landscape for kicking nitrogen out at the edge of the field, that information is already provided in this information without doing any table joins. So this C, the big difference here between the CNQ202 and the RNQ202, no huge surprise, but the suffix of the R and the C are different. R meaning a downstream resource point, C meaning a catchment or the edge of the field. So you can just sort these in descending order. So you can identify the best practices based off of the edge of field nitrogen benefits. So these are the most effective for reducing nitrogen at the edge of the field. So if you wanted to select, for example, the top 20 practices, should be these ones here, yep. And you just wanted to see what are those top 20 practices at the edge of the field, you can pop those up and identify those based off of their edge of field benefits. So just wanted to show that additional example in case that's of interest to anybody on the line here.
Hey, Rachel, maybe while you have the BMP table open, this is Drew. One more thing we could point out. I know this entire webinar series is going to be focused quite heavily on water quality benefit reductions, particularly nitrogen, because that was a focus of the local water plan. I do know within this watershed, water volume is also a big issue. The data I'm going to describe doesn't get used a ton, but it certainly has applications. So in the center of the screen that Rachel has up, she touched on T volume, but the columns immediately moving to the right of there is actually all the underpinning curve number information you'd need for standard NRCS curve number calculations. So that gets used in helping support to understand how efficient these practices would be for providing those load reduction benefits. But for those of you who are tackling water quality and quantity at the same time, it could be another kind of little treasure trove of information that makes it that much easier to start to get to those water quantity calculations, because you got the C value, the S value, the I value, for those of you familiar with curve number, all already built into those individual practices.
Correct. Thank you, Drew. Okay, with that, I'm going to clear my selection here. Maybe I already did that. I did. Close out of this, and what I'm going to do is, since I just showed the edge of field nitrogen benefits for identifying the best practices based off of edge of field reduction, what I'm going to do is just pretty much the same example that I showed on my PowerPoint slides for identifying where are the best practices for total phosphorus reduction, in this case, instead of total nitrogen, based off of their reduction impact at the outlet of the priority, of the subwatershed here. So at the outlet of the headwaters of the Prairie Creek subwatershed. So again, what I'm going to be doing is working within this table BA load red that I've been talking about quite a bit today. So you want to pull this information into an ARC map. You've already got your information in the merged together shapefile of all of the feasible practices in your watershed. So if you open up this table BA load red, this has a ton of information, as you can see by the number of files here that are selected for all of the different subwatersheds within the Middle Cedar watershed as a whole. So this is much more information than we need. So what we're going to do is we're going to trim down this information based off of what we really care about. In this case, the subwatershed of Prairie Creek. So again, we go select by attributes. And what we're interested in is priority resource catch ID equals 60. So you may recall that same step that we did the last time when we were looking for hotspots. So we're just going to let this think. And we've dwindled our set down to 2,116 files instead of many, many, many more. What you can do from here, again, is just go to export and export all of this data to its own individual table, so you don't have to deal with this million+ row of information. Again, just so you don't have to watch me do that and watch information get saved on a live platform, I'm just going to clear that selection and show the table that I've already exported here. So if you go into open here, these are the 2,116 practices or rows of information that we just pulled from the larger table BA load red. And I just retitled this to table BA load red _60 to kind of keep my own brain clear on what I was looking at. So this includes, again, a lot of information, but what we care about here now is these RPQ2O2. Last time what we cared about is the RNQ2O2 because we were looking for nitrogen. Right now we're looking for R because we want it at the outlet of the planting region. We're looking for the PQ2 instead of the NQ2 because we're concerned about phosphorus. And O2 is still what we're showing here because it's the 2-year rain event that we're interested in. So we see that this information is indeed populated in this table. So closing out of that again for the time being, we go into the all practices table again. And again, just as a quick refresher, this information was not shown in this table. It's coming in as a null for the PNQ2O2. So what we're going to do is join this information together so that that RNQ2O2 is shown in this all practices shapefile. So again, it's just a simple join. So going over to this table, doing a join and relate, and using the unique BMP ID as the feature that joins these two tables together. So I'm going to select my trimmed down version of the table and the unique BMP ID, hit OK. And we're going to open that attribute table again, now with that information joined all together. And scrolling over here, we're looking for that RPQ2O2, And now you'll see that that information is now populated. So that's the information that we want to inform our decision. So what we're doing here is we can just simply sort by descending value. And all of a sudden, we've got the best practices up on top. So the best practices that are in the subwatershed for kicking out total phosphorus before it makes it to the priority resource point that we're concerned about. So just staying with my simple example of picking the 20 best practices, we select the top 20, in this case, down to this practice here, so 20 of 2,000 selected, and we see where those are on the landscape. So this is the location of the 20 best practices for reducing phosphorus at the outlet of this planning region. From here, we can kick this information out into its own individual shapefile. Perhaps you want to use this information to create landowner maps or provide it to some board members to get their support on pursuing these practices for implementation efforts. All you need to do to that is go to export, so data, export data, and kick out your own individual shapefile. Again, so you don't have to watch my computer think. I created that and renamed it, and I already added it to the list here. So here shown on the list are the top 20 practices for kicking out phosphorus before they make it to a planning region outlet. What's interesting to note is, as you saw in the earlier example that I pulled up in the PowerPoint, I showed the top 20 locations for total nitrogen. So it's interesting to note that some of these, but not all of them, are the same practices. So that might be a great opportunity to pursue practices that are really great at kicking out both total nitrogen and total phosphorus before they make it towards a priority resource point outlet. So just wanted to throw that out there too. What's most important for us for purposes of this webinar though, is what are the benefits of all of these practices cumulatively? So to get back to Drew's point from earlier, the cumulative benefit of all of these practices together. So going back to that PQ2, or that RPQ202, can right click on statistics to get the cumulative benefit of all of these practices. The sum load reduction benefit of all of these practices at the priority resource point outlet is 180, estimated 180 pounds per year of total phosphorus. If you recall back to our slides, the goal for total phosphorus is a 29% reduction of total phosphorus. Looking at the existing loads of total phosphorus, that creates a goal of 3,807. So by implementing these top 20 practices in the subwatershed, we're making it about 5% of the way towards our total phosphorus goal throughout the watershed area. So not as much of a contribution towards our goal as the total nitrogen did, but still makes a pretty significant dent in your total phosphorus goal just by implementing the top 20 practices for total for total phosphorus. So with that, wanting to pause again to see if there are any questions about that kind of live demonstration here.
I just want to interject a comment that if folks feel more comfortable in saving their questions and asking them individually, we do have an arrangement such that in the following couple of weeks that we can get individual answers from the experts here at Houston on applying this information. So you can ask questions now, feel free, or follow up, and we can get some of those answers individually too. Any clarification on that, Rachel or Drew?
Not on my end.
Nope, and that's spot on, Jim. So yeah, we have some capacity after this is done, and maybe that's easier for folks who have a little bit of time to digest it. Maybe go back to the data and play with it a little bit, and then you'll be like, how did I do that again? So the IAWA and the way they're structured our work has provided us with some capacity to engage one-on-one after the fact as well. Good point, Jim.
And I will say too, to bring back up this screen, where are we at? Apologies for the scroll, but I always find this useful. Here. It is a lot of table names that we're going through in this discussion and a lot of R underscore, C underscore. I am certainly not the most technical person in our office. It does become kind of second nature about these table names after a while, and using a table like this attribute catalog really does help to gain confidence and familiarity with these different table titles.
Maybe the other thing worth mentioning there, Rachel, if you go to that link,
yeah,
you can also get some training materials that are actually laid out workshop manuals with the step-by-step instructions on how to build many of the map products that Rachel's been demonstrating here today, and that we'll kind of be highlighting throughout the rest of this. And just as a side note, those are basically the exact documents that we onboard our own staff with when they come into Houston Engineering and they need to learn how to use this system. So just another good resource for folks if you want another avenue by which you can figure out how to build some of these products.
Mm-hmm. So if there are no other questions, we do want to make sure that we leave some time at the end of this for discussion. But I'd like to give a little bit of a feeler about what you can expect in the third webinar here before we pause for some questions and discussions at the end of this webinar. So in addition to selecting the best practices, excuse me, I've got one chat window that's just blinking here. Can you plug that link into the chat box for downloading the help docs? Absolutely.
I can work on that,
Drew?
Rachel, in just a minute. Yep,
Thank
we'll get
you,
it before the
appreciate that.
webinar is over.
All right, great. So again, what I was showing is really selecting the best practices based off of your water quality goals, total nitrogen, total phosphorus, both at the planning region outlet as well as the edge of the field. But what I'd like to also give some time is for Drew to kind of introduce how this information can also be used to identify the most cost-efficient practices within a subwatershed. So with that, Drew, if you just want to give a quick couple minutes or introduction to what you'll be hitting in webinar number 3.
Perfect. And I did copy paste that link in there. That is to a state of Minnesota website. So everything in there is public domain. Use it as you see fit. It is not Houston Engineering stuff, although we've developed some of it and we use it for our own purposes. I will give just a quick overview here. So in the next presentation, we're going to pick up kind of where Rachel's leaving off today. You've gotten an overview of what PTM map is, what IAPA is, and how it integrates with ACPF. We've given some background on ability to target where stuff is coming from, and then how to fit that in with potentially the best load reduction practices. The next stage in this tour, in the next webinar, is going to be how do you factor in the cost information to really get at bang for your buck return. And that will be the bulk of what I'll be going over in the next presentation. You're seeing a few screenshots from what we'll be going over. The style will be much similar to this. I'm going to show a product that is one of these bang for your buck maps, and then I'll be taking you through some examples of how to build them. Oh, and just one other thing I thought of. While Rachel was presenting, I'd never really thought of it this way, but I bet most of the people on the line who have some GIS experience are familiar with the Surgo soils database. And the general structure there is, and if you're not, I'm sorry, this is going to be a waste of your time. Do something else for a minute, but we'll get you back on track in a minute. The whole structure with the Surgo soils database is you get a polygon that represents soils on the landscape, but it connects out to a bunch of different soils data that has really good information. The whole key to that thing is there's a couple of identifiers attached to each polygon, and it can track you out to multiple different tables. The structure of everything we've been presenting is much like that. The two key structures are polygons for where best management practices could be on the landscape, and then these catchments. And Rich has been doing a great job of taking you through how there's identifiers for each of those and how they connect back to different tables within the system that provide the richness of data to do some of the mapping and targeting information. So I was thinking of that while she was presenting, and it kind of occurred to me, yeah, the structure is a lot like Surgo, and I think people might kind of get that because they've had experience working with it.
Perfect. Thanks, Drew. All right, with that, we've got about 15 minutes left for questions and discussions. But first, before we do to wrap up, essentially what we're hoping that we left you with today is an understanding about how this IAPA information can be utilized in order to identify and inform where you want to spend your time, your energy, and your monetary resources for investing in conservation practices in order to accomplish a goal that you have in mind, either for at the edge of the field or at a downstream priority resource point. So in this case, we were focusing a lot of our discussion at a subwatershed outlet, but as you can imagine, the same information can be used if you've got a sediment impaired stream. You can use the same information, tie the tables and the richness of that data to that geographic location, either of catchments or of practices, as Drew just mentioned, to identify where are the best places to identify implementation efforts to make the most impact on that sediment impaired stream, so you can work towards managing that resource and hopefully delisting that resource. This information, as Drew mentioned, and as in the chat window, is all available online. The website is provided on this screen as well. This presentation, as well as a PDF of this slide deck, is also going to be made available to all of you that are on this training series. And the next webinar that Drew will be leading and Kaya will also be helping to host as well will be held on the 7th from 1 to 2:30. So we hope that this has been useful use of your time and that you've learned a little bit more about the information, and that you join us again on the 7th for a discussion about how you can use this information to inform investments based off of cost efficiency and return on investments. So with that, we've got about 14 minutes here for some questions and answers. And any comments that you'd like to make, Jim? Go ahead, Drew, I apologize.
We also encourage at this time, if you're so willing, you don't have to, pop your video back on. You're welcome to turn the mute off. This would be the time when you don't need the mute on. Encourage questions and discussions for our last 15 minutes if it's useful. And as people are doing that, I'll just say I know August 7th is a Friday afternoon. I'm sure everyone has another set of great weekend plans for camping. Just wait until after the webinar. It's going to be worth it.
Any other comments or questions, discussion from the group? Anyone?
I had a question. Hey, sorry I missed the first one, and maybe you guys covered it. And I guess as I was watching it, I kind of got the feeling that is this open source tool now for ArcGIS, or is it still something that's kind of private, semi-private, or you go over that a little bit?
Go ahead, Drew.
All right. So the code base itself isn't open sourced, but it is a GIS toolbar that is publicly available to everyone. So I'll explain that a little bit. Everyone in the world really can go to Minnesota Bowser's website, download the ArcGIS tool. As long as you have an ArcGIS basic license with a spatial analyst extension, all the functionality will work for you. The underlying code, if you're super techie and like doing Python stuff, I think the state has that locked down just so people don't manipulate it. But all the functioning the state is invested in is available for everyone to use.
Okay, thanks.
So Houston, although we're presenting it, we help build it. We do not own it. We don't retain rights, any of that stuff. The intellectual property rights are owned by the state and in the public domain.
And this work was done for the Middle Cedar just as kind of as a pilot approach. I mean, it would have to be a lot of work to replicate this again in another Huck 8, but we have this data available and just wanted to make sure people knew that it was there and had some idea how to access it and use it if it fit what projects they were working on.
Yeah, and just adding to what Jim said there, and an interesting side note in terms of shareability of this information. I know the state of Minnesota and the state of North Dakota have a licensing agreement for the web component of this system. This is just the desktop we're showing. And the state of North Dakota is using this more and more. So there is definitely an investment. Jim is 100% right. Getting the foundational GIS data underneath it does come with a cost. But I know so far Minnesota has a track record of being more than happy to, you know, share and make things available that's been developed through the state.
This is Jeff. I just have a question, kind of a follow-up to the earlier question about your data. If the prioritization of your practices takes into consideration various data tables, how often do those data tables get updated because of changes in agriculture with no-till, with cover crops? I was kind of curious how up-to-date those background tables that you never see, how often do those get updated? And I'm not a GIS person, so I can't even begin to tell you how problematic that would be. But it's just, I'm trying to make sure that the data is up to date. So when we're crunching our numbers, it's reflective of today's world.
Mm-hmm. So as part of the Middle Cedar work, PTM app and the ACPF were run to also take into account the benefits of existing conservation practices on the landscape. So those can be incorporated into this IAPA data set. So you're taking into account the load reduction benefits that those existing practices are already working towards. When it comes to land use land cover changes, that is up to how up to date your land use land cover information is that's used as an input to the IAPA data run. It does not get automatically updated unless you update the land use land cover information and rerun the data. So at that time, it can be used to update to reflect changes on the landscape, but it does not automatically populate.
And to give you a sense of effort on that, running the whole Middle Cedar, that's a big data set. The computer takes a while. But if you guys were to get better information locally for one of these Huck 12 watersheds, I would estimate you could input that data. You already have the foundation underneath it, so the level of effort's much lower, and the computer would crank out that small watershed in under a week.
Okay. And is that something that's, again, I'm not a GIS person, but is that something that a local project staff could do? Or is that going to take a level of expertise?
So to manipulate the inputs, if you say very base, I just open ArcMap and click some buttons, and that's the novice level. To advance, I can do everything and write Python codes. A general rating would be you'd probably need someone at the moderate level in the middle to be able to manipulate the inputs and rerun the toolbar to reprocess the data.
Okay.
So, and it can be done. There are local governments in Minnesota where some of this stuff has been around longer, where they've had some kind of regional staff develop an expertise in this. And I know in some areas they're at the point where they don't really even need a consultant anymore to use the data, which is kind of the vision of this thing in the big scheme of things.
Because we do with our projects, we do like to track data, or not data, we do like to track progress.
Mm-hmm.
So if we can keep those tables up to date, but do it in a format that makes it easier to do these updates, then that would help us make future calculations based on where the most bang for the buck. So, okay,
yeah,
it's possible.
And I would offer, if with that existing practices method that Rachel referred to, if someone in this group has a moderate level of GIS expertise and would be interested in connecting on us one-on-one to just get a little primer on what the structure could look like to track those polygons, that's something we could tell you guys pretty easily, because we've done it on a handful of projects around the region and have a pretty good handle on how to do that.
Okay. It won't be me.
Jeff, I'll also say too, we work with several local government staff around the state on watershed planning efforts, and they use this information as their tool for informing conservation within their large watershed implementation efforts. And they use the information about the phosphorus and nitrogen and sediment benefits for each individual practice to report compliance back to the state on using funds in a way to make progress towards their goals.
Right.
So that information can also be used kind of on a BMP by BMP basis to track progress towards a larger load reduction goal as well.
Okay.
Great questions.
Well, we've built tools in the past that try to take that in consideration, where if you had a big structure, like a sediment control structure, to build anything subsequently up above that structure would help protect the main structure, but it ain't gonna do much for below. Because your main structure is taking care of the problem. So that made that practice a low priority. And to get that caught, and how do you prioritize that? How do you tell a landowner that? Well, your farm no longer matters because somebody put a big project down below you. And that gets a little contentious. So
what we've had, that's a great point, Jeff. Where we've used some of this data to work with clients in the past is they might set a resource goal downstream, but beside that, and this gets to that resource benefit versus edge of field, they'll also put into their programs an edge of field benefit that says if you have a critical loss area, it's still important to treat that, even if we're not calculating that benefit down at the resource anymore. So we've had a client build into their program, you know, they target the top 100, 500, whatever it was for the downstream benefits, but they put a rider into their conservation program that said, if your parcel has a critical loss area, you're still eligible for our programs because that's important too.
Right. Yep.
Any additional questions for Rachel or Drew? If not, feel free to reach out afterward and we'll relay those and get those questions answered. And I want to thank Rachel and Drew for a great presentation today, and encourage folks to come back on Friday at 1 o'clock to dig into the financial side of this work a bit more. So thanks everyone for joining.
No PTO until 3 o'clock on Friday.
Okay.
Thanks, everybody. Have a good one.